I'm excited to see so many people here. And despite some of you still staring at their mobile phones, I believe that desktop is not dead yet. So, my name is Victor Kropp. I'm a team lead of Toolbox App at JetBrains. Toolbox App, if you don't know, is a small application that helps you install and update JetBrains IDEs. And, of course, it is written in Kotlin. Well, does anyone develop desktop applications here in the room? Yeah? Oh, there are some people. According to different researchers, there are some 16, 32%. Well, I guess it depends on how you ask the question, who you ask. But anyway, there are developers that are doing desktop application development. But why do they do this? Why anyone would need a desktop app? We spend like 8 hours per day at our computers, laptops, whatever. So it's a nice opportunity to reach your users. But also desktop applications have more computing power, usually. And they are not limited by the battery, or at least less limited. They have bigger screen, or 2 or 3 or more. And they are much bigger than your phone or tablet. So you can fit more information there. And they have keyboard, and keyboard not only allows you to type text faster, it also enables you with a new way of interacting with the application, using keyboard shortcuts, hotkeys, whatever you call them, to press certain key combinations and invoke some action in the application. I'm sure you already know that, but that's what differs them from the, for example, mobile apps. They are usually built offline first, and if you need to integrate with some other desktop applications, you need to build a desktop application as well. That was our case. Of course, you cannot install something on user's computer without having your application running there. Okay, we need to build a desktop application. How do we do this? First, we need to answer the question, which operating system do we target? There are like 3 major desktop operating systems, Windows, macOS, and Linux. They differ in design and in the APIs and the programming languages. They usually have their own SDKs. But take a look at these screens. These are setting screens, system setting screens in modern versions of Windows, macOS, and Linux. They look different. They have different controls there. However, at the same time, they look very similar. No matter what color they choose or what exact shape of the toggle slider they have, we clearly recognize them as some kind of actionable components, controls, and we can easily use any of them. And here, for example, even out of the context, you see that these are buttons. These are some components you can click on and expect some action to run, no matter what their size, shape, font used, or color. And that's why cross-platform applications are a thing. You can have a generic UI not tied to any operating system, but instead to have UI more near to your design system, to your design language of your company, your application, and have it running just fine across all the operating systems. And also develop it once instead of targeting different languages and frameworks. Okay, but what options do we have? We want to build a cross-platform, modern-looking, and small application. I have an answer to this question today, but back in 2015, when we started, the situation was a bit different. So the Kotlin was not released yet at that time. We didn't want to write in Java either, and we didn't want to bundle JVM with the application or to write components in Swing. We didn't want to use Electron and write everything in JavaScript. It was just not our thing. So we kind of decided, it was a forced decision to write the business logic of the application in C++ and get a native executable for each platform for easy integration with the operating system. But we wanted modern UI, so and we had a developer very capable in React and JavaScript, so we went with this choice. And to some point, it was a good decision. We've created the very first version of the application of our Toolbox app in just 48 hours during the internal hackathon at JetBrains. It was fully working application. It could list all the projects. You see the old design of JetBrains from back that days. It could install IDEs and so on. So it was a success, and we continued to develop this application and improving it. And well, at this point, I guess you may ask me why the hell this guy is talking about C++ and JavaScript at Kotlin Conf. Fair question. We thought the same. Why do we do everything in C++? Because it's a complex language, complicated. It is very easy to shoot yourself in the foot with C++, and even smallest mistake leads to a crash of the application. And it was very hard to hire developers for this. And we also had two parts of the application which need to interact with each other, sending megabytes of JSONs back and forth, even in the same process. So we decided to change this, and in 2020, we've rewrote the business logic in Kotlin. It was quite a challenging task to bring everything intact from C++ to Kotlin, but thanks to regular expressions and clever refactorings in IDE, we've managed to convert everything, including tests, to Kotlin. And most of our users didn't even notice that. But for us, it was a big deal. We were able to develop faster and with fun, as always in Kotlin. But our UI was still written in JavaScript. And all this resource consumption caused by sending JSONs back and forth between two parts were still there. But the last missing piece of the puzzle arrived shortly. We were approached by the Compose team at JetBrains. They were porting the brand new Jetpack Compose framework from Android to desktop. And we were their first clients. It was an exciting collaboration between two teams. And in 2021, just like less than a year after, we've released the first version of Toolbox based on a Compose Multiplatform. This was a mutually beneficial collaboration between the two teams because they got their first real-world use case with like millions of users already there. We've got a framework we wanted. We provided a lot of feedback. We helped to shape up the APIs. We've reported bugs, and our users reported bugs. So what's the takeaway here? I guess if you can have your UI framework team sitting in your office next to you, it is cool. But just joking, don't do that. Use some proven, tested framework developed by the big companies that have millions of users. And this is the case with Compose. Compose is already tested on Toolbox App. We've been releasing it new versions like every several months for 2 years already, and it works just fine. Why do we love Compose? Why did we choose it? First, Compose is using Kotlin. It is written in Kotlin. Most of its parts are pure Kotlin code. And for the UI you develop, you also use Kotlin. And it means that you got all the features. Like null safety, extension functions. Compose heavily uses the Kotlin's ability to build nice DSLs. You've got all of this. Compose is declarative. So you declare the UI how you want it to look like, and the framework does everything behind the scenes to render and update the UI whenever needed, based on the state you provided. So the simplest possible Compose application looks like this. And it is truly amazing that in just 2 lines of code, you can already have a window on the screen with some text there. Of course, it requires some setup. Thankfully, IntelliJ has a project template for you. If you create a new project and you choose Compose Multiplatform there, it will set up a Compose compiler and necessary dependencies for you. And it even can then package your application for different operating systems too. Okay. Next, Compose is cross-platform. And I specifically say cross-platform here, not multi-platform, because in the Kotlin world, multi-platform means something different. Compose for desktop targets JVM and runs on JVM. And this is how it achieves a cross-platform ability. Well, maybe some time in the future we'll see a truly multi-platform version of Compose for desktop, but it's not yet there, not yet planned. And it works on JVM just fine. Again, it is proven by millions of users already. Compose uses coroutines under the hood for almost virtually everything. And it also allows you to nicely integrate your coroutine-based APIs, like I don't know, state flows to manage state. And Compose is also testable, and I cannot underestimate the importance of this fact, and we'll get back to it later. Let's start with Declarative. So here's how a simple update button is defined in the Toolbox app. So I will show the examples of what we have in Toolbox app. They are very simplified, of course, because in real application you have a lot more details, state, and so on. But here we see that you just use your familiar DSL constructs to create a button and put a text inside. And if you slap a preview annotation on it, you can see the component rendered right inside the IDE with the Compose plugin. Well, maybe this is familiar to you if you are an Android developer and you're already using Compose in your application, and this is true. This is the same Compose framework that you are using on Android, and in fact, it shares the same artifacts, like for example, for compiler plugin, it is exactly the same. It transforms these composable functions with composable annotation and adds some boilerplate code there that you don't want to write by hand. And it has the same runtime, which is pure Kotlin, by the way, which manages states, and like foundation UI components, components without any design system that are containers to have a list of elements, or text fields without decoration, with just an ability to enter some text. So yes, if you are doing Android development with Compose, you can do desktop apps too. You just need to create a new project or a new module in your application, add some desktop-specific dependencies, and you are good to go. And if you are not yet developing with Compose, whenever, wherever you do your development, mobile or desktop or server side, you see how easy it is to start with Compose. It's just a few functions with familiar syntax constructs. Compose doesn't introduce anything new to the language, except this small composable annotation, which is completely transparent in your code. And given Compose comes from the Android, there are a lot of documentation, for example, and a lot of examples and a lot of questions on Stack Overflow about it, and like 99% of them apply to the desktop code too, because they are the same. But there are still some specific things specific to desktop. Like, for example, we usually have a mouse on our computer, trackpad, whatever, and we can put mouse cursor on top of the button and expect some tooltip to appear. And it is done just like that. You wrap it in another composable and provide the content for the tooltip, which is, again, composable. You see, you compose your application from different components. And like here with the tooltip, you are not limited to just text. You can put images there, whatever you want, with any formatting and so on. Unfortunately, these tooltip cannot be previewed in the plugin right now because all the previews in desktop plugin are not interactive, but it's not a big deal. You can see individual components just fine. You can extract this tooltip out of the this tooltip area composable and check how it looks individually. Next, I was talking about the keyboard shortcuts, and you can, of course, intercept them with Compose just fine. And the Compose provides a modifier to handle key presses, and if you want, you can extract it to another modifier or composable, and everything will be handled by the framework. So we just do this, and it already works fine in Compose for a desktop. And speaking of the familiar language constructs, if you want to put a list of items on the screen, like here we have a list of tools in Toolbox, we just use a regular for each loop and to iterate over the list of components. In some other UI frameworks, you need a special component to handle a list of tools, or you have a specifically designed list components that can only do that. In Compose, you are not limited to it. You can use the things you are used to. And if you don't like these traditional for each loops, you convert to for each extension functions to iterate over the list, and it also works just fine. It helps a lot to read and understand your code, to refactor it later, and to onboard new developers to the project, even if they haven't done any UI development before. And we have successfully did this already in our team. And yeah, it worked. It just works. Everybody can start doing Compose like in a few days. And another thing that works out of the box is keyboard navigation via pressing a tab key. So if you have a focusable components in your desktop app, you expect that if you press tab key, the focus will move over these items. And if we have this like column of menu buttons on the right side with these three dots icons, we just press tab and it works out of the box because all default components come with this thing pre-enabled. And you can make any of your own elements, controls, focusable as well. So everything one would expect from the desktop app is already implemented and working in Compose. Okay, let's go next and talk about tests. If you do any kind of UI development, no matter on what platform are you, do you test your UIs? Well, you should. But UI testing is complicated. And the usual approach for testing the UIs is screenshot testing, where you render your UI, you take a screenshot of it, and compare it to some reference image. But it comes with some issues. For example, I took these screenshots on the same version of the application with the same tool installed, but on two different operating systems. One comes from macOS and one is from Linux. And I don't know which one is which. And I bet you cannot distinguish them either. And if I try to blend them together, there is no difference there. Well, we don't see the difference, computer does. And if I highlight the different parts, you see a lot of differences here. Where do they come from? First, Compose uses Skier for rendering. Skier is a native library used, for example, in Chrome browser, also for rendering. And Skier delegates font rendering to the operating system. And it means we have different font rendering implementations on different operating systems. And even in different versions, they may differ. So given this exact same font file, they render text differently. And then if we add different settings, like different anti-aliasing settings, pixel densities, UI scaling, pixel alignment, and so on, we receive completely different pictures. We can freeze some of these parameters in our tests to fix them, but that will usually mean that we are only limited to a specific operating system, and we cannot test this UI this way across all the supported operating systems. Compose supports screenshot testing as well, but it also has a much better option for you to try. So let's get back to this tools list component and try to test it. And to do that, we will create just a regular JUnit test. And all we need is to add a compose test rule here by the function provided by the framework. And what it does, it sets up and tears down the framework for each of our tests. So next, we just write our usual JUnit tests by using this test rule and setting content which we want to test, like a virtual window or compose scene. Let's set our tools list to display just a single item. And then we can verify that the item is rendered. This is that easy. I haven't seen the UI testing made so easy. And that's not the only thing. We can, for example, verify that something is not displayed on the screen just like that. So if we don't expect any updates available, we can assert that update button does not appear. This makes troubleshooting and verifying that you have your bugs fixed much easier. Okay, but if the update button exists, we can go even further and emulate a click on it. And this function alone is a treasure. I've been doing development of desktop apps for quite a long time, and I haven't seen testing made so easy like it is with the Compose. With the old-style frameworks, which do not have any testing which did not enable any testing inside it. You usually need to rely on some third-party tools to emulate clicks on your window. You need to create a real window of the application and then pass coordinates of the button somewhere, and this framework will do a click for you, and it usually requires a real screen, connected mouse, for example. It's just a mess, which is very unstable. And usually, if anyone tried to create this test, what I've seen, either these tests were testing nothing, nothing really interesting, or they were quickly becoming red and abandoned. With Compose, you write the same Kotlin code in the same project, and you can apply all the refactorings there, and it is much more stable because it asserts everything structurally rather than relying on how it is rendered pixel by pixel. And after we emulate a click on this button, we can wait for like animations and while we are processing this click and assert that the download has started. Okay, next are coroutines. Consider this example. We have a tool in the list, and we click on it, and we want to start it, and we want to display some visual feedback that we've registered the click in our application. And indeed, the IDE is started under the hood. So we display this opening label for a few seconds, and then switch it back to the version number. How do you do this without coroutines? Likely you need to start a timer or maybe even a thread, background thread, and then you need to manage it and cancel if I don't know, another click comes in or the component disappears. With the coroutines and its integration in Compose, you have everything you need right inside your composable. You can start a coroutine whenever the state changes with the launched effect. You can delay 3 seconds, and if you've been using coroutines, you know that it is a very cheap operation, it doesn't consume any resources, and then just change the state after the 3 seconds are elapsed. And you display the text, just switch the text just with the regular if statement, and everything is re-rendered when the state changes. And framework takes care of this coroutine. It cancels it if the state change comes from the outside, and so on. So just few lines of code that save you a lot of headache. And what's even better, we can test it. You see how different features come together to provide a really great developer experience when developing apps with Compose. So we set up our virtual window with this tool label. We don't need everything to be put in there. We may just test just a single component. We assert that at first it displays opening text. We wait for 3 seconds. We assert that the text has changed to the version number. Wait, but how do we wait these 3 seconds? Do we really need to wait 3 real-world seconds for every time we run this test? Of course not. If you've been testing coroutines before, you know that coroutines are dispatched by the dispatcher, and the Compose is not exclusion. And in test framework, you can stop the clock at the very beginning, because otherwise it will run everything at once, and we will not be able to test the label at the start. But then we can advance time by 3 seconds, wait for animations and so on, and assert that the resulting text is displayed. And all of this runs almost instantly. So you can write whatever complex test you want for whatever lengthy actions you have in your app, and they will run just in a few milliseconds. I haven't mentioned it before, but animations are also great in Compose, and why I'm talking about them here is that animations are under the hood based on coroutines. So let's take a look at this example again. We have a text here which is changes depending on the state, and we want this change to be smooth. So for example, we want to apply some fade in, fade out animation when the text is changed. Well, with Compose it's easy. You just wrap everything in animated content, and voila, it just works. Of course, you can provide some additional setup for this animated content, change the way how transition works, the length, and so on. But just simple as that, you wrap everything with a animated content, and it already gives you a nice look and feel. So there are no more excuses not to use animations in your application. And it applies not only to the built-in composables like animated content, you can also use user-defined animations just in the same way. So for example, we have this rotating chevron. Let me zoom it in, which is shown in the list of tools. It shows whether it is expanded or collapsed. And it is implemented in the same way. We have an angle where this chevron is pointing. It's just a single icon, and we only rotate it when the list is expanded. And to do this, we just launch a coroutine, and it animates the angle, so it changes it smoothly over time. And it is a suspendable function inside the coroutine, which means that you can stack your animation, run them sequentially or parallel, whatever you want. The only limit is your imagination. You can have also some complex animations, predefined animations like these Lottie-based animations. Lottie is a vector scalable format for animations. It is much more efficient than animated GIFs or videos. And if you are using, if you are developing some mobile apps, you may have heard or already used it because it's like kind of de facto standard in the mobile apps. And it also works with Compose because it is rendered by Skia just as well. And we have this nice animation welcoming users when they first start the Toolbox app. There is a huge catalog of these animations in lottifiles.com. Most of them are free to use with the Creative Commons license, so you can just add some nice touches to your application. And while we are talking about some community content and some look and feel, we need to talk about themes. So Compose originates from Android, and this means that it is, of course, comes with a material theme, and you can use it on desktop out of the box. But you are not limited to it. In fact, there are already many community-driven projects to create different themes for Compose on desktop, which are, for example, the Jewel project that intends to implement IntelliJ design system on Compose to make it easier to develop IntelliJ plugins in Compose, because Compose components can be easily integrated into existing Swing applications. And if you, for some reason like we, do develop an application in Swing, you can use Compose inside your application too. There are projects like native theme for Compose, which emulates native controls for macOS and Windows, or this Aurora theme that goes in completely different direction, but allows you to highly customize the colors, for example, of your UI. So there are already lots of different projects out there. So, to recap what we have seen today. Compose for desktop is already stable and ready to use, and it is proven by millions of users of our Toolbox app. And there are other applications, third-party out there, and we also experiment with the Compose in different projects inside JetBrains too. Compose runs on Kotlin, which means you have all Kotlin features available for you, and coroutines as well. If you have coroutines-based APIs, they just integrate in your application easily. And you have nice animations out of the box, which are highly customizable. And you can test your UI to be sure that everything works as you expect it to work. So, I had a question in the beginning. What framework, what technology stack to use to start a mobile, or to start a desktop application in 2023? Well, if you start your desktop application today, there is no better way to do this rather than use Kotlin and Compose. And with that, if you can write some Kotlin code, you definitely can create desktop applications too. Thank you for your attention. Please don't forget to vote and enjoy the rest of the conference.